Hello everyone, this is Mix K. This is my second review video on matter and the periodic table. In this video, we're going to talk about how we classify matter. So you probably have a paper that looks like this in your notebook, okay? And I printed out the notes just so you guys could read them better. So this is a little graphic organizer to help you classify matter. Now, scientists split matter up into different groups to help us think about what they have in common and what makes them different from each other. Scientists always like to put things into groups. So these are some of the major groups of matter that we have. Now first, we discussed this. Matter is anything with mass and volume. So it has to, remember, mass is our scientific word for weight. Okay, so it has to weigh something. Volume, it has to take up space. So if it doesn't have mass and volume, it's not matter. So something like a thought. A thought does not take up space, even though it might feel like it does in your brain, and it does not have mass, so it can't be matter. It also is usually made of atoms, and I'm going to add something, or particles. So particles are just the tiniest pieces of atoms. Okay, so it has to have mass, volume, and be made of atoms. Now, we have two different types of matter. We have pure substances and mixtures. So let's start with the pure substances, because they're not mixed with anything else. So in a pure substance, all the particles are identical. So every small piece of matter, okay, every small piece of matter in that substance is the same. All the smallest pieces are the same. And remember, a particle can be an atom or a molecule. So pure substances, it's all the same tiny pieces in that substance. Now we can split this into two different categories. And actually I want to highlight as I go. So I'm going to make my definitions for pure substances in green. Okay, so pure substances. And now I have elements and compounds. So let's make that blue and yellow because that's what comes together to make green. Now elements are made of only one type of atom. Okay? So this means that the smallest piece of an element is atoms. And they're all the same type. So it's a pure substance because there's only one type of particle and all those particles are the same atom. Now, atoms or molecules can be made of the same, sorry, I'm reading this wrong. This can be atoms, like I said, all the same type of atom, or it can be molecules that are made of the same type of atom. So something like O2 has the same type of atom. It's just connected, so it's all O's, so it's going to be an element. Now, compounds, on the other hand, are made of more than one type of atom bonded together. It has to be bonded. If they're just two atoms mixed, that's a mixture. So two or more made of more than one type of atom bonded together. So that's going to be molecules, like H2O. Can you read H2O on there? Yeah. Okay. So we have pure substances. All the particles are identical. Every tiny piece is the same. Elements are made of one type of atom. Compounds are made of two or more types of atoms bonded together. Now let's look at mixtures and then we'll come up with some examples for all of them. Okay, so mixtures are more than one type of particle together, more than one substance mixed. Okay, so they're mixed together. So here we had one type of particle, here we have more than one type of particle to make a mixture. Okay, now the first type of mixture is called a homogeneous mixture. Now if you think about the prefix homo, you might have heard it before. You might have heard it in biology class for homogeneous, which is the same. I know it means the same and it has to do with genes, but I don't remember what it means because I'm not a bio teacher. Or you might think of homosexual, which is someone who is attracted to the same gender. Okay, so what a homogeneous mixture is, it's a mixture that is the same throughout. It is mixed so well and so evenly that everything in that mixture looks the same. So with homogeneous mixtures, you have to think a little bit and make sure that you're thinking about what it's made of, because it's going to look like it's one thing, but you have to know that it's made of more than one. So it looks the same throughout. A mixture of more than one thing, but it looks the same throughout. Now, heterogeneous mixtures look different throughout. Okay, so they're not mixed well at all. You can see the different parts in a heterogeneous mixture. And to help you with the prefix, hetero, like heterozygous, you have different genes, or if you're heterosexual, you're attracted to a different gender than your own. So let's go look at all of our different examples and come up with some examples. So elements have to have one type of atom. So this could be O2. It's still one type of atom, even though there's two oxygens. They're both oxygen. We could have gold. Anything on the periodic table is going to be pure. Another good example is diamonds. Diamonds are made of pure carbon. Okay. Now, let's draw an example of this. I want to draw O2. So what I'm going to do is a little circle is going to represent an oxygen atom. And because there's two of them bonded together, I'm going to have my little oxygen molecules looking like this. Now, if we look, all of the atoms are the same. They're all the same little circle atom, okay? So that would be a pure element. Let's think about compounds. So I already told you H2O, water, is a compound. Another good example that you know is salt, NaCl. And sugar is a compound. It's C6H12O6. So let's do water for this one. So I'm still going to use the circle for O, and I'm going to use a little dot for H, okay? So for this one, they have to be bonded together, so they're connected. But if you look, every small particle is the same. It's all H2O. The difference is there's two types of atoms, and that's what makes it a compound. Okay, so one type of atom, element, two or more types of atoms, compound. Okay? Now for mixtures, we need to have them mixed together. So some good examples of homogeneous mixtures. Sugar water. What's another good example? Gatorade. Your Gatorade is a bunch of stuff, but when you look at it, every sip's going to be the same. This is one that you might not know, steel. Steel is a metal, but it's a mixture of other metals. So it's mixed so well that it actually becomes stronger than the original metals. Now it has to be mixed evenly, because if it's not, then your steel girders that you use to build buildings aren't going to be very strong, and they're going to have weak points and they're going to break. So in steel, they mix it so well that every sample has the same amount of each metal. Now for this one, I want to draw 2 cups, because I want you to imagine, we're going to do sugar water. I want you to imagine I mixed sugar and water together and I poured it into 2 cups. Both of these samples should be exactly the same and the same throughout. So I'm going to use a little water droplet to represent water. And I'm going to use a little square like a sugar cube to represent sugar. And so as I go through this, it's going to have them spread out evenly. Now I'm going to draw it like this so you can see that everything is spread out evenly in this material. And over here it should be exactly the same. Okay, so it's the same throughout. If I mix sugar and water together and I pour us 2 cups, it's going to taste the same. Okay, now for a heterogeneous mixture, let's think about a couple things. A good example would be something like trail mix, which is a mixture of a bunch of different foods in a little bag for you to eat. It could be beach sand, because if you take 2 scoops of beach sand, one might have a shell in it, one might have just sand in it or a rock in it. You could do the dirt in your backyard. If you dig up 2 scoops of dirt, one might have a worm, one might have a bug. So let's draw as if we took 2 scoops of beach sand. So I'm going to use dots to represent the sand. Dots equals sand. And then we can think of some things we might find in there. So if I took 2 scoops of beach sand, I might find a seashell over here. I might find some seaweed over here. I might find a little crab in the sand that I'm digging through. I really just wanted to draw a crab, you can tell. Okay, I might find a rock. Okay, it's not going to be the same in each of those scoops. Okay, so when you take two scoops, if they're the same, exactly the same, it's homogeneous. If you take two scoops and it's different, it's heterogeneous. And this is for mixtures. Okay, so just in review, matter. Anything with mass, volume, and it is made of atoms or particles. A pure substance has all the same type of particle. So if all those particles are the same type of atom, it's an element. If there are two or more types of atoms bonded together, it's a compound. For mixtures, we have two or more types of particles mixed together. They're not bonded to each other. Homogeneous, they're mixed so well that they're the same throughout. Homo means same. Heterogeneous, they're not mixed well, so they're different throughout. Okay, hetero means different. Okay, thank you guys so much. Have a great day.